Next up, Mr. Steve Love is going to share a talk called C# version 9 records. Now, because of his internet connectivity, he has pre-recorded this, which ruins the entire sense of jeopardy. But either way, here's Steve Love talking about C#.
Hi, I'm Steve, and I want to really quickly introduce C# records, introduced in version 9, which came with .NET 5, which was released in November 2020. So records are described as a new way of creating value types in C#. And I was interested because I thought, well, C#'s already got a value type. It's called struct. So what is it that records are all about? And this is some of what I discovered. So what's a record? It's a new way of creating a user-defined type, and instead of using class or struct, we use the keyword record. And this case is called a positional record. And what we're actually creating here is a type called point, which takes two parameters to a constructor called x and y, or two int parameters, and they're also exposed as properties with the same names, as we can see in the usage in the little tests there, where we're pulling out the x and y properties and asserting that they're equal to the values they were given in a constructor. So this simple one-line declaration actually obviously hides quite a lot of other stuff, including the fact that it performs value equality. What that means is that when we compare two instances with the double equals operator, or indeed the equals method, it's comparing the content of the type rather than the identity. So again, we've got a test to show this, that the two record values that we're comparing are in fact equal by value, but if we check that if they're equal by reference, that's false. But they do copy by reference, so when we assign one to another, we just get reference equality. There is another way of assigning where we can use non-destructive mutation. We're using the with keyword. Here what we've got is that copy is being assigned to coord, but they're no longer reference equal, and we've created a new value with slightly changed properties, and we've selectively chosen which properties we want to change. Records can also inherit from other records, so we could inherit a point 3D from our point, and the semantics of inheritance for records are broadly the same as they are for classes, and we can cast up and down the inheritance hierarchy, and we have the substitutability of between the derived instance and the base class reference. So let's have a look at some of what it's competing with. Here's a struct called point3d, and instead of inheriting, which we can't with a struct, they are implicitly sealed in C#, we're containing an instance of the underlying what would have been the base class for the record. And overall, we've had to write quite a lot of code to represent this, including our own equals method and get hash code. So how do they shape up when we compare them together? Let's have a bit of a contest. Nice little method that creates a list of quite a large number of instances and then turns it into a hash set. So we're exercising both equals and get hash code here, and deliberately creating a list that's got duplicates in it so that the two hash set has to do some work, and then run this test for both the record point3d that inherits from its base class and for the struct that contains the point instance by value. And what do we see? Well, for the hash set of records, the whole test took about 5.5 seconds. What's interesting about this is that when we did it for structs, it's a little bit quicker, but equals doesn't even register. So for the profiler, I'm using the JetBrains profiler to run this through, called .trace. It's a handy tool, and this is just basically a wall clock time. More interesting, perhaps, is what this toList is on about. For the structs, it's a little over half a second. For the records, it's over 3 seconds just to generate the list. So this isn't even doing the get hash code stuff. What's going on here? It's because under the hood, records are actually emitted as classes. So they live on the managed heap and they're subject to garbage collection. So the cost of garbage collection is important for records. So some recommendations to come up with at the end. Positional records are great and the non-destructive mutation is great, but remember that records are heap objects and don't forget that we can use structs instead. Thank you very much.